Right, well, we've got another set here from January. Make sure I don't show marks from Stowmarket's letter. Not working. Yeah, right. So it's another set that's come with side screws. When people send sets in, where there's normally being trade only, the dealers know this, don't send these side screws because they're very easy for us to lose, and they're very difficult to replace if we do lose them. I'll put those in the box. So these sets can suffer from dry joints. It's come with the factory original microphone, and we will power it up from our crocodile clip lead. I don't have the power leads for these. Usually when these do have the dry joints, it's usually under the VCO. So you've got to have the faff of taking all the screen plates out from underneath. So it's a real faff. But other than that, they're good. Is this the D version, I think he said? Yes, it is the D version. I know people probably half jokingly say D for deaf. I've not found any performance difference between the two, but I do prefer the other version, which isn't the D version. I don't know why, I just prefer it. I think other people probably do, but I've never seen a technical difference. So we'll start this off at full voltage because it's not like it's an unknown set. Switched it on. Of course, it starts up on channel 9, which is... Oh, that's why I hate these. Yes, because it doesn't have a real channel switch. It's just an up-down. It's really just an up-down switch. So it's what's called a rotary shaft encoder. It's a bit stiff, like it's got something nasty in it. Anyway, so this, when you switch your set off and unpower it, and then power it back up, it'll always come on channel 9, and that is frustrating. A lot of sets did that at this era. So it's going to transmit. We've got it connected to test gear. I'll put picture-in-picture on. And it has no transmit. So let's see if it's got receive. It's not even hissing. So I've got the signal generator on full whack and it's not receiving. And I'll just in case we've got a duff speaker, we'll just plug in the extension speaker. So it's absolutely dead set. So, you know, you could say, well, perhaps the microphone lead's faulty or the switch in the mic's faulty. But I would still be receiving a whacking great big signal from the signal generator if that was the case. So it isn't. It may be in these sets that if there's no VCO running because the synthesizer's not running, it may be that it mutes receive totally. So that's what we're going to look at. Well, I'm going to be taking all the screws out, so we'll probably edit the screwdrivering bit out, though I'm pretty quick with a screwdriver. When you're a church organ builder and you've got 200 screws to put in everything, you soon learn to be quick with a screwdriver, although of course on pipe organs they are not Phillips screws, they are slotted, and they have to be or we wouldn't pass inspection. Right, so first thing we'll do is just pop the speaker off. So chances are it won't have been fiddled with, it's just gone wrong. And chances are that the malfunction's under that screen plate. Right, we'll take the power off and unsolder the screen plate. There's no point looking elsewhere. Look here first because this is the hardest thing to look. It's like looking at in an index and it's A to Z. So you start at A and you actually find that what you're looking for is Z. You've just had to go through 3,000 record cards. So you think, well, I'll swindle the system. I'm going to start at Z, and you know perfectly well it's going to be B, don't you? So you think, well, I'll start at A, and then go to Z, and then go to B, and then go to Y. And of course it's right in the middle. Because that's how it works. Not sure why this one isn't coming off. Unless it's got two. Yep, it has. Right, I'm going to have a look for dry joints. We'll just pause the video. Right, so I've found a few dry joints and it's now showing me a full signal. So going to transmit, and does it do that? No, it doesn't. I'm going to try another mic with this because the fact we've got receive, we should have transmit. Drop the signal generator to there and let's see whether we can actually hear it. And the answer is barely. We also can use a sex toy type vibrator on this, and there's one on every bench, I can assure you. Mr Chippy didn't come with me the time I went to the pound shop and bought a number of those, and I made sure I didn't take a carrier bag, so I walked out with them as they were. Right, I'm going to press transmit first, and we'll just give it some tap. I think we'll go for the we'll go looking for another mic for a start. Okay, so coming back onto this a few hours later, Mr Chippy has had this on his bench and he's been going around for dry joints, and yeah, so we've got we still have it receiving, but I've got a clue here. We've got no transmit, we've got no receive, but when you actually look, that wire's been cut short and something added, and that wire has been messed with as well. And I'm just wondering whether somebody's decided to rewire the microphone socket a different way. So I'm going to get Mr Chippy to open up another Midland 77104 and we'll just see how the wiring is done, because that's probably what's happened. Okay, fast forward a bit forward, Mr Chippy's got to the bottom. As I thought, the wiring must be different on that mic, so he's compared it with another set we got, and that's why we have one of every set. So we can now hear that. So I'll go from the extension speaker to the instrument speaker. Just like that, and put that on. No, we can't put it on one side because in there is my adjustment diagram. So having done the dry joints, which is why the VCO wasn't running, and the microphone socket rewired back to standard. This is bizarre, because why would somebody rewire the microphone socket and yet it come with a microphone? Well, we're on our test microphone, aren't we? Let's see what happens when we plug in the factory original mic. It's fine. Right, so we'll carry on with the factory original mic from this point. Now there's going to be a difference here because, yeah, this is going to be fun, because the layout's different between the D version and the earlier one. Not sure why that's missing. It may not be missing, but it's something we'll check. Yes, totally different layout, isn't it? Right, we'll start by seeing if it's on frequency. 2779107. We'll just bring that spot on. It's not stupidly out. There we go. Let's go back to the normal main meter. So at the moment we're doing 4.5 watts. So we still have to peak this. So that's peak. And I'll check with the other set whether that's supposed to have a core in or not. I suspect that that is done on a spectrum analyzer. I may have to dig out another circuit diagram. I'm not going to touch that at this stage. So have we got a preset for power? Because if not, we may have to lower it by other means. So let's see. That's going to be, chances are that's going to be squelch. Chances are that's going to be deviation. Let's see if that's deviation. Wow, it's a bit low actually. That isn't deviation. The chances are that is. Yeah. Wow, that's now too high. Let's try it there. Wow, that's now right. So TX meter at the moment, we've got all 4 lights on. Let's go to low power. So in low power we've got about 0.3 watts. So one of these is going to be low power. So it's not that. It's not that. I say one of these is going to be low power. It may be preset low power. So let's see whether one of those adjusts the meter. At the moment it's on one light as you'd expect. So that is meter. So I'm adjusting it so one light just shows. So when I flick it to high power, we've got all 4. So it's done on low power. That is how it's done. So I suspect that's going to be S meter. S meter. I suspect that's going to be squelch. So what would that be? If that's deviation, let's just go back to low power. Well, that is not low power. That is not low power. That is in fact power. So we can now set that to 4. So 4 watts RF power meter. So now on low power, the radio is 270 milliwatts. So it's preset on this model. So far so good. I'm obviously going to have to do another photograph of this version like I have with this, and print it out like this with it coloured in. So I think we've covered transmit. I want to check that with the spectrum analyzer. I'll come back to that. So receive at the moment, as the radio is presented, let's have a look what it's doing on the SINAD meter. So right now it's 1 microvolt for 12 decibel SINAD, which would be better if it was about 0.7, but we'll see. So I'll drop that to 4 dB. We'll just look at the oscilloscope and just make sure that with an S9 100 microvolt signal I've got the detector somewhere in the right place. So there's the detector coil. Little improvement there. Good. That's what we like. So we'll go back to 4 to camera 4. Just drop the volume a bit for those who find it annoying. And we've got 3, 4 for your IF and front end. That's quite an improvement. Check it was on a bigger signal. On a smaller signal. Okay, just pause the video. Right, so we've got optimum. Let's see, we'll read that off now again. So now for 12 dB, we have got improvement. It's 0.84 microvolts. Now we yet to put the bottom on and the shield plate. So that's nice. It's nice, always nice when there's an improvement. So let's look at the S meter. So I'm going to put S9 signal equivalent on, 100 microvolts. We may as well go over to the attenuator. So we've got plus 30. We want it to be 9. So I now suspect that that's probably the S meter. It is. So we'll just set that so it's just not plus 30, and as we increase the signal on the signal generator, get plus 30. As we reduce it, that comes down like that. So now we know that's squelch. So we're going to turn squelch to full. This is the radio that hisses when it's squelched. And I want this squelch to open at 100 microvolts. So we're at 0.3. So 1, 3, 10, 30. There's 100. So although I messed about with that, I'm just going to mess about with it again to prove that I'm right. Yeah. So that is squelch. So now we will do the opposite. Turn the signal generator to standby. I've parked it at 0.3 of a microvolt. Turn the squelch down and set threshold. Now then when does it open up? Well, that's no good. That's 100 microvolts. Let's try that again. No, it's no good at all. That's 100 microvolts. We're going to have to set this differently to what's normal. So we're going to have it so the maximum is 30. Let's try that. Right, now we'll do the opposite again. Set threshold. No, I can't get this to set. Maximum. I take it the squelch control actually works and it's not shorted out. Let's try it at that position. Right, try that. That's better. So it's opening now at 1 microvolt. Let's see exactly where it's opening. 0.85, dropping off at 0.45, so it's got a good range. So now let's see where full squelch is. 100 microvolts. You've just got to be so careful on how that's set. So right now that's working fine. Well, that wasn't easy. That's taken probably the longest part of the video, setting the squelch. So I'm going to take a photo of this and we'll take it from there. Okay, so we'll finish this off. So I've printed off a 77104D. So I've put away the 77104 ordinary. So I've got the full instruction book here. It's got the square kit diagram. I just wanted to look at that coil, didn't I? See whether we've got to look at it on the spectrum analyzer. Let's see what it's called. It's L204. I think the answer is yes. Yes, it's so there's the output transistor. I'll put the spectrum analyzer on and we'll just look at that. I'm not expecting it to need adjustment because this radio hasn't really been messed with as far as the tuning goes, but we'll just look at that. Right, so I'll put the spectrum analyzer onto the inset picture. I'll see if we can find it on auto. I'll key up. No. Right, we'll put the fundamental frequency in of 27.79125. So now when I key up, we're in low power. Yeah, we were in low power. No wonder I couldn't see it. Okay, so I can see that, and I can also see, if we move it along, that there at the as a harmonic. I'll measure that in a moment. We'll just see whether we can reduce it with the adjustment there. Look at that. Right down. Right down. So it had been twiddled. So we're still doing exactly 4 watts. So I was right to check. Let's go back to our fundamental. See if we can measure that. It's so small, it's minus 63 dBm, something like that. So that's got rid of it. So I'll just show you the meter on for the transmit. So there's the 4 watts. It's exactly the 4 watts where it should be. Low power is still 250 milliwatts. I'll make a note of that because we're going to do a low power test, and this is the lowest low power because the others have all been adjustable with the 3 prior ones. So this is low power on this is 250 milliwatts. It's preset, which isn't ideal. So I've done a diagram, and I put transmit spectrum analyzer, and I was right. The other thing I need to just check, because we had to open that setup, we had to open another setup, as I said. So we've got the squelch, we've got the S meter, we've got the receive detector, we've got the 4 receive coils there, we've got the RF meter, we've got RF power, which is the high power. So we've been able to set that to 4 watts. We're peaking those for maximum. That's the one with the spectrum analyzer. We didn't touch the VCO, and that was the squelch, which was, you've got the frequency, you've got deviation. I'm just going to pause the video again. I'm just going to check with our other set, which we had to open up, to make sure that shouldn't have a core in it. And the answer is no, there isn't a core in that position. So the other thing I'll need to show you is why did Mr Chippy have to do what he had to do. So here's a photo of the mic socket, and there's his little circuit explanation from starting at that pin. That pin goes to chassis. there's a earth tag goes to chassis. That wire goes to the 4th pin along, 1, 2, 3, 4, and that is where the earth goes to the printed circuit board. Then on these 3 you've got capacitors, and one end of those of course goes to this earthing ring. So you've got earth, capacitor, capacitor, earth, capacitor. So it's that green wire, isn't it? Is that. Then you've got ferrite beads with inductors on. You've got these inductors go to those 2. So you've got the blue wire, the green wire with the inductor, the green wire without the inductor which goes to earth, and then the orange wire with an inductor. So that's how it's wired. So at least I've got that on file now. We won't have to take another one apart. So here we are. It's another one sorted out. I just need to put the screen plate back and hope that it still works when I've done so. So I'll put the smouldering iron on. So we think somebody's either changed the front, it might have been a tatty front, or they've changed the socket for whatever reason. And although they got the wiring right, what happened was, go back to this diagram, is they'd missed the earth off. So they'd put the green wire to that pin, but it has to link to that lower pin and link across to there. So all that had happened is all the green wire was doing was going to the earth side of those capacitors. It wasn't doing anything else, and that's why there was no receive and no transmit. So there was no nothing because of dry joints, then no receive and transmit, and this hasn't worked since somebody changed that socket or front panel or whatever they did. So I'll ask the customer where he got it from. Interesting. So Mr Chippies done a nice job of the dry joints, and all I need to do is to put the screen plate back, and all I need to do is find where I put it. Oh, you won't believe it, but our friend Stuart's just driving by, so he's in range. And there's Mr Chippy on our base station, Tango 21.
Tango 21, good evening.
Tango 21, I'm actually recording a video at the moment, and we're just working on a Midland 77104, and I've got to the point in the video at the end where I'm about to flick round the channels.
Oh, excellent. Well, good evening. We've just come into Wilsford, and I do believe we'll be going past Scratchy Corner very soon.
Oh, that's not fair. You're doing an on-the-air test.
Well, it wasn't intended. Yeah.
Okay. Right, I'll let you talk back to Mr Chippy, and I'll flick round the channels.
Yeah, okay, Richard.
Right, well, I quickly put some screws in when I heard them talk. I'll put the rest in later. So we'll just finish our video off. And annoying channel switch, we've already said about that. Let's turn the squelch down. Now, Mr Chippy's causing bleed over. The aerials are about 15 feet apart. Right, so we'll leave it at that. So I didn't have to go one Hannah Roger. I'll pop some more screws in this. I'll put the rest in behind the scenes, and then we'll do an on-the-air test tomorrow. So it's Friday night at the moment, so I've been working on this on and off throughout the day. So remember, it was nothing working because the VCO wasn't running. The VCO wasn't running because of dry joints. Once we got the VCO running, the radio wasn't transmitting or receiving, although it was clearly receiving because the meter was lighting up when I put the signal generator on the appropriate frequency. So passed it across to Mr Chippy because I saw the wiring around the microphone connector and I thought somebody's wired it wrongly, and then it transpired, as I say, that they'd actually missed the earth off. So that's why it wasn't transmitting or receiving. So a tune-up's brought it up to 4 watts, and I did have to put it on the spectrum analyzer, which I didn't expect to have to do when that coil had at some time been adjusted when it shouldn't have been. So I'm very pleased with the result, and it isn't deaf. And there we go. So thank you for watching the Midland 77104D UK version, which I think were about 1985, 1987-ish.